I'm Sunny with the Be Kind crew, and I want to welcome you to Connect2STEM TV. Organized by the University of Arizona College of Medicine, Phoenix, in partnership with Cox Communications and the Arizona SciTech Festival. Who's ready to get nerdy? Today, we are going to have fun and work on a STEM project. Be sure to have your materials. Get ready, set, let's go.
So welcome to geometry, and creating sort of a quick overview of this, and then feel free to go ahead and go crazy and enjoy this. Because one of the questions that people always ask is, in a math class, is where am I ever going to use this? You know, and there's a lot of applications for mathematics that aren't just sitting in a classroom doing some work, you know, online or on a worksheet or something like that. And a lot of artists are actually mathematicians. And so you're using the math that you're learning in class, you're just not realizing it sometimes. So let's create some art. So the first thing you're going to need to do is get out a piece of paper. And what you want to decide is, what shape do I want to make? And one of the most important things you want to do with this is make it something called regular. And do you know what a regular shape is? So the regular shape, we want to make sure has the exact same lengths for all of the sides. So if you're going to do a square, a triangle, a pentagon, or whatever, you want to make sure that they all have the same length. So you will need the ruler. Now a question might come up is, but I don't have a ruler. You know, how can I do that? Well, this is where you can get creative. You know, you can take something like, say, a business card or some playing cards. And if you use that same edge every single time you draw, whatever your shape is, you're going to have the same length. So we take this. This is going to be hard to do because I'm looking up here. We're going to take it. We're going to take our paper, and we want to put that shape probably up in the corner. So I'm going to make a square, and I'm going to make everything 2 inches long. So, hey, look, I've already got half of that made. So then take it, measure it out, make your marks, and then cut along the sides. So cut out your square. You're going to end up with something like this. And my advice is make more than one, because, you know, doing one, okay, this is not going to, it's going to be a little bit harder to do. So I've actually got several. I made 4. You can see them all right there. And so I've cut out the 4 of them so that I can create whatever I'm going to create with my art, but I have multiple of the same copy. And so thinking smart, hey, we want to make sure that we're working smart, not hard. You know, because working hard, you're going to do a lot of extra work. But if you're working smart, then everything goes a lot quicker and you're able to do some more things. So we take it out and we get out our scissors and we cut out our thing. Got my shape. So what I want to try to do now is create something that, you know, is a repeatable pattern, because what we're going to make is something called a tessellation. And when you think about tessellations, it's something that repeats over and over and over again. You know, so you could think about things that you see, like maybe tiles on the floor. Those are a tessellation. When you see murals on the side of a building that are made out of tiles, that's a mosaic. That's also a tessellation. You can think about a lot of things where you see that repeating pattern, and that's a tessellation. So what we want to do is get out yet another piece of paper, a brand new whole sheet of paper, and take our shape that we've cut out and just put it somewhere and put it in whatever shape. So here I've got it as a diamond, maybe I've got it as a square, maybe I've got it in the center of the paper, maybe I've got it over off in the corner, maybe I'm just putting it in some random spot, because it doesn't really matter. You can do this however you want to do it. It's totally up to you. So we're talking about just some basic things here, but you have the creativity to be able to do what you want to do with it. Okay. So I'm going to put this on here. And then I'm going to do some tracing where I take what this is, and you can call this your template. You can call it I forgot the word for that. So, okay, this is your template where you're going to use this and repeat it over and over and over again. And so what you want to do is get that piece of paper and just start repeating that shape. So you can see here, I've taken that and I've drawn it a couple of different ways. And notice how this is a really kind of a rough sketch. And that's fine, because what I'm trying to do is create that pattern across the paper, and then I'm going to clean it up after I get to a point where I'm ready to start doing some more with this. So, this is kind of rough, but you can see the pattern starting to develop here. And I want you to think for a minute, it's like, what do you notice? What's something that you see here that's happening with this? And then what's going to happen is I start getting to the edges of the paper. And getting to the edges of the paper is fine. You're going to have partial shapes. That's no worries. So what's going to happen, this is a really interesting thing. And so think about this. We are naturally drawn towards the center of these things. Why is that? Why do you think that happens? What is it about these shapes that are happening here that you think is going to draw your eye naturally to the center here? So take some time, and you want to draw this out and fill up the entire piece of paper. Don't leave any spaces like this. This is just a rough sketch, but actually start drawing it out. Draw out what is this going to be? And this is going to take a little bit of time. Quite honestly, I'm a terrible artist. I can't draw straight lines. I do horrible things with this, and I'm going to make mistakes. And making mistakes is okay, because you can make it look however you want it to do. What you want to make sure that you're doing is you're keeping that same pattern happening, which is why I made multiple of these, so that I can say, okay, am I keeping that same shape going through? And you can lay it inside of there, and oh look, still keeping that same shape as I'm making my art. So we want to make sure that as you're going through, that it stays the same. Right? And so this is a good time to just kind of listen as I'm talking, as you're making your art. One of the great artists of the Italian Renaissance was Leonardo da Vinci. And when you look at what da Vinci has done, obviously his most famous painting is the Mona Lisa, but you don't really think about da Vinci as an inventor or as someone who's built some crazy things. And he did a lot of interesting things. He actually made a tank. What? You don't really hear about that very much. He made things like catapults. He contributed all sorts of things to mathematics. And some of the writings that he said has very much hinted at that his love of art brought him into that space of, I'm curious, I want to explore things, let me just try stuff out. And so when you think about, the mathematics that you're learning now, it really is, we're getting you ready for whatever it is you want to explore. Because everybody in here has potential. You just have to decide what you want to do with that potential. And so taking this math, and not just thinking of it as I'm sitting down, I'm doing a worksheet, or I'm sitting in front of my computer and answering these questions online, but actually, hey, how could I apply this? If you start thinking about math as how you apply it, you're going to open up your mind to a world of different possibilities. So at this point, I hope people have drawn out their spaces, mapped out what they're going to do with this. And then what we should do is take those terrible lines that I had there and really kind of darken them up. So I used a Sharpie here, you use a pen, you could use whatever, or just take your pencil and really push hard onto that and really kind of darken it up. And you can see I've got my partial spaces as I'm coming through here, coming around the sides, and that's the nature of how this works. So whatever shape that you have on there, square, triangles, whatever, you're going to have these partial shapes. So it's okay. One of the things that I would say is make sure that you're taking this and you're really kind of darkening it up. So that way you can see, all right, these are my definite lines, and it looks a little bit cleaner. And then we're going from there. So here comes the question. Is now we want to make this not black and white. Black and white's fine, but color really makes it important. So taking a look at this, we want to start putting in some color here. And the question that I ask you here is, how many different ways can you have a color not touch another color? So we've got this four-sided shape. So if I look at this square here, and I'm going to say this is a white square, but now these squares that are on other pieces, I can't leave as white, right? Corners, yeah, you can leave that as white. But if you've got a side touch another side, we don't want to have those same colors touch. You know? And so let's say we want to work smart, not hard, because we've done all of this work and we don't really want to have to go back and redo all of this again. So I'm just going to kind of mark in here what I want to do. So where unfortunately I don't have a camera where I can put this down and make it look cool. So here we go. So I'm going to sit here and I'm going to say this is white. Hey, it's already white. I'm not going to mess with that. All right. So coming up to this next one, I'm going to make this blue. Okay. So now I know that this one can't be blue, but this one could be white because it's white here and it's not touching another side. Okay. So I can make that white. So now I come over here. Oh, I can make this one blue again, because once again, only these corners are touching. That's okay. But the sides, they can't have the same color there. Right? So then this one could be white. This one here, oh, this is another one we can do blue. And then we can do white, and then come up here. Oh, this one could also be blue. Okay. So you can see I marked those all with a B, so that I know as I'm getting ready to do my coloring, hey, all right, I know what colors it's going to be. White is white, it's already done for me, and then the rest of these are blue. But now stop and look. Do you notice a pattern? What is that pattern that you're seeing? Right. And at this point, this is where, you know, you can, I'm going to recording, and you can do this and then ask some questions. But the question I want to say is, all right, we did a 4-sided shape. We did a square. What if you did a 5-sided shape? Is there another pattern? What if we did a 6-sided shape? What if we did a shape that is irregular? And irregular means that all the sides aren't the same length. What if we did some kind of crazy shape that's not a regular polygon? What if, you know, I took a picture of my cat and put it on here and then trace that over there? What's going to happen? Okay. So one of the things that we want to think about is, what's the pattern that you're seeing here? Because mathematics really is about patterns. What's the pattern to what we're doing? What's the pattern to what we're seeing here? So what is the pattern that you're seeing as you're doing this? And can you do something where the pattern changes? You know, how does the color affect, how does the shape affect the color? And so with that, I want to say thank you for watching this, and then we'll be in the Q&A. You can ask whatever questions you want to ask. All right, thank you very much.
All right, that was wonderful. So be sure to ask Bill your questions in the chat, because that's a lot of information, and it was fun. Welcome, Bill Pike. And who knew we could make art with math? That's amazing. You did a great job.
Oh, thank you. And it's always interesting watching yourself when you're recorded. So, so you know, really the thing that I want to make sure that comes across is that mathematics and art really go together. And then you can take that patterning with anything you're doing with any kind of math and then apply it to something else. And there's a whole world of, where are you? How does this work? You know, and I taught math for a long time. I remember being a math student and really asking the question, where am I going to use this? And so this is just one example. And there's millions of examples out there. And so really take a look at what you're learning and how does it apply outside of a classroom? Because mathematics is beautiful and you can do a whole lot of things with it.
Well, Bill, why don't you tell everyone what your role is at the university?
Okay, so I work in early academic outreach at the University of Arizona, and I coordinate a program called Mesa, which is Mathematics, Engineering, Science Achievement. And we work with middle school and high schoolers, primarily with underrepresented students, so first generation, low income and ethnic minority students, to get them excited about going to college and the path you need to take to get there while you're in middle and high school, and then get into STEM. And so what we do is we have several different challenges that we offer to schools, and then you can build a solution for that and then compete in our annual event called Mesa Day, which is usually at the end of April. This year's going to be April 24th, and compete against other teams across the state for medals and prizes for your school. yourself.
That's great. So were you always interested in math when you were growing up?
Yes and no. So when I first started at the university, I was actually going to be an engineer. And I realized that I did not want to be an engineer because I like spending more time with people than I do designing or building something. And so with all the engineering work that I had done, I already had a strong background in mathematics. And so I became a teacher. And so one of the things that I always want to do is say, this is something that you can apply because, too many times the question was, when am I ever going to use this? And so I really did a lot of work into, well, here, this is where you're going to use this. And so, as you're going through school, nobody's ever sure what they're going to do what they're going to do when they are adults. I'm 45. I'm still not sure what I'm going to do. But how are you going to use this and doing that really real world application? So as you're working through there, what are you interested in, and how does the math apply?
It's interesting. So you were talking about, math and everyday use. And I think we do use math. We may not just recognize it. For instance, in cooking, cooking is something that many of us do. Me, not so much. But, it's interesting following the directions and the measurements and things like that. Math comes into play. It's very, very important to be able to have that. So, so here's another question. Where else is math used that we wouldn't think about? So we've talked about cooking, but what else is there something that might be very obvious that we do on a daily basis or weekly basis that we wouldn't even think of it as a math, a problem or something that we're doing with math in the math world?
Okay. Actually, one of the things, and I just saw in the chat someone said alarms. Absolutely, that is definitely a spot where you're using math. One of the things that I thought about is I have a lot of pets. I have a couple of cats, a dog, some fish, a snake, and the amount of food that we need to have for them is really huge. In that, I have a lot of pets, and so you can put that in there. As part of, well, how much food do I need to give to the cats versus the snake? When do they eat? Because my snake only eats once every 2 weeks, and so am I giving the nutrition that they need to continue being healthy and happy? And in one case of one of my cats, a total spaz. So doing with that. And I saw in the chat someone put music. Absolutely. Music is a huge space involving math. And one thing that you may not realize is that musical chords actually fit a pattern involving the square root of 3. And so when you think about, say, the C chord, when you're doing the major thirds for that, the lengths of the strings and how it mixes together actually is, if you call the middle C 1, then the next third on that, which is F, would be the square root of 3. And then if you go up to, and I'm already forgetting my music, A, that's 2 times the square root of 3. And then when you go to the next C, that would be 3 times the square root of 3. And so there's that mathematical pattern in order to create beautiful music. And when you look at major and minor chords as well too, there's a whole more complex relationship.
And that kind of goes back to something that you said earlier about math being about patterns. So that's another example of math being about patterns. Is there another example that maybe you could think of about that comes to mind about patterns in math? The example?
So one of the things that, and this is more high school space, is if you think about trigonometric ratios, they all use the numbers 1/2, root 3 over 3, and root 3. And within that, they go through a cyclical pattern, which means they're basically going around in a circle. And you can take that and actually apply that to the cars that you drive, moving things that move in a circle, and how those ratios apply to all of that. So anything with a moving part is involving that pattern with the circles and the trigonometric ratios.
Good, very good. So what advice would you give someone, perhaps if they're in middle school or high school, and they have an interest in math, what types of some careers would you maybe perhaps say that math could be a core part of?
Math can be part of anything, because as you look at the world as we're developing, we know that the careers that middle school students and even some high school students are going to have after they finish college don't exist yet, because the world is changing very quickly. And so companies are looking for people with strong math backgrounds. And you may not be someone who's like, I have a degree in math, but I have a strong math background, and that will help you out as you're going through there. If you have a degree in mathematics and you just go to a company and say, I'm interested in what you do, I have a degree in mathematics, there are companies that will find a position for you and they will pay you very well, because a lot of business analysis, just technologies that we're using nowadays, all involve the mathematics that are in the machines or in how they want to make a better profit, or in whatever product they're developing, is all going to be involving with math. And so having that math background is really key to getting out there and saying, I want to make, our goal is to make a lot of money and help people. So you can make money with a strong background in mathematics and STEM in general. And the one thing that I always like to say is, failure is an option. Just keep trying. Everybody fails. I failed multiple times in my life. I'm sure you can talk to people who said, I failed too. And just because you failed doesn't mean you need to stop. There's actually a way to prove things by proving that it can exist. So that has to fail. And so therefore it has to be true. So keep trying. And if you fail, try to figure out why, because failure is not an end to a journey. It's a step along the way. And so whatever happens, if you're like, oh, I really don't get this, I don't understand it, stop, take a step back, look at it and try to look at it a different way, or ask questions and then try again. And that perseverance will serve you well in anything that you do moving forward.
Great words of advice. In fact, there's many sayings out there that in many ways we learn more from our failures than we do from our successes. So that's great. What do you like best about your job? You're so good at what you do. What do you like best about your job?
So I made a very conscious decision that I want to work with students. And my growing up background, I did not grow up with a lot of money. We struggled for a lot of reasons financially. And so I wanted to tell my story to the next generation, and the next generations to say, look, you may not have a lot of money, but you have talent, because talent is equally distributed across everybody, race, gender, whatever you want to call it. So everybody on this call has talents. Use those talents, whatever you're going to do. And if you go into STEM, awesome. If you decide you want to be, a musician, awesome. If you want to do something else, that's great. But everybody has talents, and use those talents. My talent is I'm mathematical. And so I'm leveraging my own personal talent to do what I want to do. So mathematics is one of those bases that can really help you achieve your goals. And so keep trying.
Again, great advice, and you are such an inspiring teacher. That definitely comes through. And I think it's also important because, unlike you, I was not real keen on math growing up. It was something that kind of eluded me. I was better at writing and expressing myself through the written word back then. So I always struggled with math. So I always admired people that were able to pick it up so quickly. But I think that's also important, is to know what you like and not what you don't like. And, find that passion and be able to take that and go with it. Because every one of us, like you said, is unique and very, very special. And being able to find out your purpose and your passion is great. But leave all your options open is what I say. Explore. It's a wide world out there. So it's wonderful. Well, Bill, do you have any other words of wisdom or any other things you would like to leave us with today?
The thing that I always tell people is don't stop learning. Every day that you learn something new is a good day. And that could be something with mathematics. It could be something that is Just something like, hey, I learned that my dog doesn't like this kind of food. So keep learning. Lifelong learning is huge. And when you stop learning, life becomes boring. So keep learning, keep trying. Excuse me. And I understand that, someone put in the chat, math is a language and it can be hard to it can be hard to translate. Totally agree. But the thing is, keep trying. I need to drink some water.
Okay, you go ahead. All right. Well, thank you, Bill, for being with us today and for sharing your words of wisdom in that great exercise that we went through and learning that art and math do go together. We also want to send congratulations to Jason, who is this session's winner of our Connect2STEM t-shirt that Bill and I are rocking today. So thank you all. And we want to make sure today was just the very beginning of Connect2STEM Live TV. We're going to be with you every Saturday this February, so be sure you'll see the link in there in the chat function. Check that out. If you haven't registered yet, please do so. You register for each Saturday, and then you're open to all. You'll get the Zoom link for all the sessions. So, Bill, thank you so much for being with us today. I am going to share my screen.
Thanks for everyone for being here today, too. Really appreciate you spending some Saturday with us.
Yes. We enjoyed it. You were wonderful. Thank you so much. And so we'll do another thank you from the Be Kind crew and a special message.
Learning about STEM is fun. Be sure to check back for more Connect2STEM TV. There's lots more to do. Don't forget you need to register here. Special thanks to our sponsors, Banner Health, APS for their great support. And be sure to follow Connect2STEM on Facebook.
All right. Thank you all for joining us today. We hope to see you again next Saturday, again with more fun and STEM activities. Take care, be safe, mask up, and bear down.